Well, good morning, everyone. My name is Richard Gordon, and I'm Technical Director for the Spring Manufacturers Institute. I'd like to welcome you to this special webinar on Electropolishing 101. I'm delighted you could join us today. We've got several students with us from prior SMI webinars. Welcome to you all. Our training course instructor is Scott Potter, Vice President of Sales at Able Electropolishing Co. Incorporated. Scott's been with Able for 36 years and has experience with many applications where electropolishing has been used to improve performance of springs. This webinar is being recorded and will be available to SMI members on the SMI website. First, I'd like to provide some background information about the Spring Manufacturers Institute that some of you may be aware of and others may not. The mission of SMI is to serve, support, and educate North American spring manufacturers to assure competitiveness in world markets. SMI was founded as an association in 1933 when 33 companies that manufacture springs and their associate suppliers joined together. Members of SMI work together to meet key issues in the industry worldwide in areas such as quality, materials, technology, and government regulations. SMI provides services which include our quarterly magazine Springs, technical publications, spring design software, industry data, seminars, meetings, safety and regulatory compliance support, and of course, technical assistance and training. Our technical assistance includes things like answering questions about fatigue life and fatigue testing, corrosion problems, materials-related problems, but also development opportunities, process-related problems, interpretation of standards. We have a formalized failure analysis program that many members participate with. And again, we have our training and spring design assistance. Our training session today is planned for 45 minutes, followed by a 15-minute question and answer period. At the end of class, we'll ask you to complete this course evaluation that was sent to you via SurveyMonkey. If you didn't receive the course evaluation SurveyMonkey, please let me know in the chat and I will send one to you. We look forward to your feedback. Now, in terms of housekeeping, we ask you place your computer on mute. You can ask questions as needed during the presentation, either by unmuting your microphone or via the chat icon on the Microsoft Teams screen. If you do use the chat, please respond to everyone so fellow students can see the questions. Scott will also address questions at the end of the presentation. And of course, if you need to increase magnification on your screen, you can do that by pressing the plus icon at the bottom of the screen. So why is the subject of electropolishing important to spring designers and manufacturers? In our Advanced Spring Design class 301 on fatigue, we discuss failures that occur in springs. As we categorize spring failures in our failure analysis work, there's several mechanisms that are involved. But both SMI and others have found that over 50% of failures are due to fatigue. Now, fatigue damage is caused by a combination of cyclic stress, microscopic plastic strain, and tensile or shear stress. As we have learned, a fatigue fracture occurs in 3 stages: crack initiation, crack propagation, and catastrophic fracture of the remaining cross section. Where do cracks initiate? Cracks typically initiate at the highest stress location. We learned that the highest stress location on springs is at the surface. And for compression springs, the highest stress location is at the inside diameter of the spring due to the spring helix. So our mission or goal is to increase resistance to crack initiation. Now, in our fatigue class, we discussed several methods to improve spring fatigue life. These include modifying the spring design, selecting a higher strength material, selecting a higher quality material with improved surface, selecting a material with improved micro cleanliness. We can preset some springs, shot peening, electropolishing, and low temperature nitriding. Now, although we show electropolishing and low temperature nitriding as methods, these are not discussed in the 301 course. So today we've got the opportunity to explore electropolishing. So now I'd like to turn the presentation over to your instructor for the day, Scott Potter, Vice President of Sales at Able Electropolishing Company, Incorporated.
Good morning. Glad everybody could join. Again, sorry for the little glitch there. Appreciate everybody taking time out of your busy day to join me and spread a little information about electropolishing. You may or may not be familiar with electropolishing, but hope you find it worthwhile. Just a little bit about our company. Obviously, our main forte, our main service is electropolishing. We also offer nitric and citric passivation, vacuum vapor degreasing. We also offer part review on teams. If you have something that looks like it'd be a good candidate for electropolishing, be happy to schedule a teams meeting to go over some of the details and what you're trying to achieve. Also, we offer free samples and prototyping support. Typically, samples run in 24 to 48 hours at no charge. Kind of gives you an idea right off the bat if it looks like it's something that's going to work for you. Gives people a chance to be able to do some testing and so forth. We also we have in-house surface testing and analysis. We've bought a bunch of new equipment here this past year. We've got a laser microscope, a high definition microscope. We've got an SEM as well. We use it a lot for root cause analysis here internally, but we can also use it for checking roughness average and so forth. Been in business since 1954, going on over 71 years. Got 150 employees. We run 3 shifts, 5 days a week, equally staffed, and we have a 50,000 square foot facility. As far as customer experience, we actually have a dedicated customer success manager for your account. We have 2 customer success managers that presently. It's kind of nice because they can see your orders, coming through. They can do quotes, run samples, so they have a one person contact for many different things. Integration. We've spent a lot of money on automation. We're up to 14 robots now. Definitely improves consistency and capacity. And then with the automation with the vacuum vapor degreaser, we also reduce emissions. It's definitely the green way to go rather than have the open top degreasers. As far as expansion, we got 5 new electropolishing lines in the past 5 years. We got 23 total lines. And then we also have an automated rinse line that we added in 2019 to improve consistency of rinsing as well. As far as certifications, ISO 9001 2015, ISO 13485 for the medical device group, and also AS 9100 2016 for aerospace. Some of the materials that we can electropolish nearly any material with the exception of precious metals. Full range of stainless steels, precipitated hardness stainless, unusual alloys. I'll get involved with some unusual alloys through Carpenter and so forth. Carbon steels, copper alloys, aluminum, nitinol, titanium, tool steel, specialty exotic alloys. It's worth noting that the nitinol and titanium parts, the refractory metals, are electropolished by very few houses. We definitely have, because we make our own electrolytes here, we've developed electrolytes for refractory materials. The benefits of electropolishing, corrosion resistance, microfinish improvement, deburring, ultra cleaning, durability, and fatigue life improvement, which obviously involves springs, improved cycle life for springs, decorative finish, bacteria and other pathogen resistance, and improved conductivity. I'll go into more detail as we get along here. Benefits of electropolishing for springs. The big thing with springs is removing micro cracks that develop during stress from forming. We want to make sure that you remove those initiation sites where premature failure can occur. Improve corrosion resistance. The electropolishing improves corrosion resistance by 30 times compared to that of passivation. You have a lot of parts that have been heat treated. They're looking to remove scale and looking to get the parts down to the base metal. Increase cycle life, reduce stress concentrators, allowing springs to endure more cycles without fatigue or failure. Superior durability, protects against wear and tear from repetitive use, ensuring reliable performance in demanding applications. Electropolishing, many of you probably are not familiar with electropolishing. You're familiar with plating. Electropolishing is like a reverse plating process where the reverse polarity of plating. The parts are actually made positive. The cathode is negative. We're actually removing ions from the part and drawing it toward the cathodes, and the material is actually suspended in the electrolyte. Electropolishing versus passivation. Obviously, electropolishing removes material. Passivation does not. Passivation is really designed to remove free iron from the surface. If you look at ASTM A967, for example, readily used spec, the scope is really it's for removing free iron and other contaminants from the surface, trying to get the part back to the original mill condition. You can see there, actually, the passivation, in some cases, you can actually get flash attack. You can actually, it can be detrimental to the actual surface of the material. Corrosion resistance, expand on this a little bit more. I mentioned it's 30 times more corrosion resistant than passivation alone. We're actually moving that outer skin of metal, that amorphous layer that's developed. I guess I had a question about what is flash attack. Flash attack is when the grain boundaries of the material are actually attacked chemically. So you get an adverse reaction between the chemicals and the actual material. So it can actually be detrimental and can actually cause premature fatigue life failure. And so, yeah, flash attack is a definitely something you want to avoid. Sources of carbon, carbides for machining and stamping, embedded scale, grinding compounds, sulfonated lubricants, steel toads, pans, contaminated buffing wheels, polishing compounds, heat effects from welding. One of the things that most people don't realize is when you weld something, you actually change the metallurgical structure of the material. You get what's called carbide precipitation. You're actually drawing the carbon to the surface. And it actually can compromise its corrosion resistance. Here's a case study. One of our customers shared this with us. They actually show the exposure of the 420, 410, 304 stainless and Trinimet. Um, and you see the exposure after 24 hours, and you can see after 888 hours, the electropolished parts show no rust. But the passivation, obviously, parts that are raw do show the advent of rust. Another case study we did. We've got some weldments there. After you can see after 144 hours on the auger. That auger on the bottom, the 430 stainless auger is actually for ice machine for uh, a freezer, a standard freezer that somebody would have in their house. Um, and then so that's an actual part. The weldments, we actually had a customer weld these up for us and for purpose of demonstration. So you can see the parts as passivated, they're starting to develop some rust. Um, and then, but the electropolished parts, you can see that the weld um, on the wire weldment is nice and clean, no corrosion, and then same with the auger at the bottom. The burring benefits, one of the things that's nice about the electropolishing, it's non-distorting, where a lot of the burring processes are bulk. They're done with a media. You can actually have problems with part-to-part contact. Fragile parts can become distorted. The electropolishing, the fact that the parts are racked, you can um, you can protect the parts from actually going out of spec and becoming non-conforming. Electropolishing removes fine blanking burrs, milling burrs, broaching burrs, lapping burrs, and grinding burrs. We're on the micro level, so typically our burr removal is more microscopic because we're removing normally about 5/10,000 to a thousandths total material, either diametrically or off of thickness. Um, One thing is we're also very effective with most configurations. The fact that you're submersing the parts into an electrolyte, you can get into a lot of little nooks and crannies, a lot of areas that a media would not be able to, like in the fiber finishing. There's some SEM photos that I've got. It's a medical part. It was a fastener, 316 stainless part. They were actually, believe it or not, they were hand deburring these parts. You can see the slotted head on the left there has a large burr. And electropolishing consistently moves the burr from the slot, moved all the other contamination from machining as well. Um, Improves the corrosion resistance and micro finish all in one operation. Here's a stainless surgical drill with a grinding burr. You can see that lateral uh, burr there. This on 100 magnification. You can see how the electropolishing, cleaned up those edges. One of the questions people have, they're concerned about how much radius that you get on an edge, and typically the radius that we achieve is twice that of the stock removal. So if we're taking 5/10,000ths off a thickness or diameter, you're going to get like a thousandths radius. It's kind of rule of thumb. So it's a slight break. Um, it's enough to be able to take that burr off and put a slight radius on there. Another shot. This is actually at 500 mag, but you can see how nicely it cleaned up that edge. And they're concerned of any kind of debris. Obviously, in a surgical application, worry about any kind of debris coming dislodged, during surgery. This is actually a blade. This is consumer item. This is for a peeler that you'd use for peeling potatoes or vegetables. Um, they actually use the electropolishing to establish the final edge. It takes off that the ragged burrs and then creates actually a sharper finished edge on that peeler. And with the burring, the big thing is it's not necessarily the height of the burr that's critical. It's actually the base of the burr. How substantial is it attached here? It's kind of like a little whisker. We're able to actually clean up not only the burrs but also improve the micro-inch finish on this aerospace component. Here's before and after the burring example on titanium under high magnification. It's pretty astounding when you go into the SEM and see what's going microscopically. Fatigue life improvement. Obviously, the be interested in this topic with springs. The electropolishing removes small imperfections that might become initiation sites for premature failure. Good for parts that flex, cycle, twist, or bend. We do a flight critical part for Apache helicopter. It's actually it's a support for the main rotor, and it has to twist and flex under G forces. They use electropolishing to make sure that there's no defects or anything in the surface that are going to cause premature failure. One of the things that with electropolishing, it can be used alone if your parts something it can't be shot peened. Otherwise, the best results typically with electropolishing is when it's used in conjunction with shot peening to compress the stresses from forming. Here's one of our customers. They sent us a part that it's actually a chrome silicon material. It's a valve spring for a NASCAR engine. And well, obviously they're concerned about fatigue life, and they want to make sure that the valve springs are lasting through the races. You can see how the electropolishing kind of moves. We call it kind of like the notch effect. When you're forming springs, from the stress from forming, you have a tendency to create little notches, little imperfections in the surface. In the electropolishing, you see where it typically improves the microfinish by up to 50%. Removed some of the minor imperfections that might lead to premature failure. Here's a stainless steel spring. You can see too the improvement. And typically, whenever we have a part like a spring where it's difficult to use a standard stylus profilometer, we'll use a laser microscope here that we can actually use to get real good accurate RA readings before and after electropolishing. Can also get very accurate dimensional readings as well. This is one of the piece of equipment that we added here this last year, and it's nice because the stylus. Another reason the stylus can be work to your disadvantage is it'll actually scratch your part because of the fact that it's traversing back and forth. It will leave a little scratch on your part, which is not good. But yeah, so this is something that we have, and we provide an additional service to the standard profilometer. Here's a chart, kind of gives you a little idea as far as micro-inch improvement as that relates to the stock removal. You can see on the left there, on the graph, you're starting out at a 16 RA, and as you take more stock removal, you get you get that gain in the RA surface finish. You see where it took it down to an 8. Typically, the rule of thumb is that with 1,000 stock removal, 5/10,000ths per surface or per side, you're going to get 50% improvement. So that's a key benefit. We have a lot of customers sending RFQs, and they calls out a 10 RA, and they're just saying we just can't get there with our machining and subsequent processing after machining. So they use electropolishing to be able to meet spec. Here's a stainless steel fastener. It's pretty dramatic. You can see the electropolishing gets down um, in between the flutes, where typically maybe like a tumbling or vibra finishing process would not. But it's in one-stop shop. You get all the different benefits in one process. Here's a gear before and after. Obviously, they're always concerned about the gears mating properly, making sure there's no debris that would become dislodged and cause issues with function of the assembly. So it's pretty another pretty dramatic shot there before and after. There's a night null wire that we electropolish. Do a lot of wires. Do a lot of night null is 50% nickel, 50% titanium. It's used for implants. It's very it's very good. It stands up in the body very well. And we do a lot of wire form, stent-like parts that are implanted in the body. But one of the things that makes it difficult to electropolish is it's because of the fact that it's very very good for standing up to the situation, as far as blood and so forth. It's also hard to break down. It's hard to break down with our electrolyte. So we actually have a specific electrolyte that we developed with Fermilab. We were actually working on some niobium parts for Fermilab, and we were able to work on something that worked well on the refractory metals and inert metals. So it's becoming very widely used in the medical device field. A lot of people are familiar with grit callouts. Here, for mechanical finishing purposes, if somebody mechanically polished a part before electropolishing, it kind of give you a relationship here of grit and RA. You can see you starting out at a rougher grit, 80 grit, going all the way down to a 400 grit. You can see what the relative RA levels are to the different grits. Now I'll move you forward here, and you can see after electropolishing, the improvement. See, it goes 59 all the way down to a 3. I'll go back to the last slide. You see where you start out at 106, went down to about a 4. You can see the improvement with the electropolishing. This is typically with 1,000 stock removal. But there's a lot of people who don't talk RA. They talk grit. They're more used to standard mechanically polished parts. This is just kind of a guide, because sometimes in order to reach the end goal as far as RA, people have to do with subsequent secondary operations after machining. This is just kind of an idea of what you're going to get as far as improvement, using mechanical polishing with electropolishing. Ultra cleaning benefits. People looking for contaminant-free parts. We do a lot of sanitary parts, food, pharma, medical, aerospace, semicon. People looking for a part that's very passive and clean. One good thing about the electropolishing, it's not there's nothing to peel or abrade from the parts. It's not a coating like a Teflon or some kind of a plating that eventually can wear off. We're treating the base metal. And then as far as removing, it removes embedded scale, very light blush rust, foreign debris, grinding compounds. It removes weld discoloration as well. Um, Also, a lot of people use it to improve their weld integrity. Want to make sure that they're welding onto a good clean surface so they get a stronger weld. And again, it's non-distorting. With the electropolishing, you don't have to worry about the electropolishing parts that are thin or fragile. We can typically electropolish a part up to about 4 thousandths thick. It's about this as low as we can go. There's a case study of beryllium nickel alloy. You can see how the slots were EDM'd, and then they were heat treated afterwards. So um, the electropolishing is very effective in removing the embedded contamination, and also the removing the recast. It's a big it's a big thing for a lot of our customers. They're concerned about that remolten layer that you get on the surface, that recast layer that you get with EDM. It's a false surface on there, and it's prone to failure. So a lot of people use the electropolishing to remove that recast layer off and to remove any embedded contamination as well. This is these parts are unusual in the fact there's a number of different steps that we actually perform for the customer. It's actually a ratchet system that's actually used by people that are doing rescues, firemen, actually used by window cleaners. But it's a critical part. They actually sent us the parts. We actually degrease the parts. Then we send them out for heat treat. Um, then we send the parts out for the face, the opposite face to be blasted. And then we do the final electropolishing, which you can see on the right side there. On the left there, that's what the parts look like after heat treating. So you can see how the electropolishing moves that heat treat, improves the microfinish. Um, but yeah, they were handling the subsequent secondary operations besides electropolishing themselves, and they're like, hey, we don't want to deal with it. So we said that we would control the outside processing on it, and it's a very good customer. Their parts are here all the time, and also they actually make parts are used on sailboats as well. Here's an example. It's a weldment. It's it's a food rack of some sort or shelf. You can see the weld discoloration from the resistance welding on the left there, and you can see how the electropolishing cleaned up that discoloration. As I mentioned, you clean up that carbide precipitation situation and leave the part very passive, clean, and improves the cleanability as well. Things don't like to stick to it. There's another example of a grid for a grill. We did a lot of these, did a lot of grills back during COVID. We actually have a large robot that can handle up to 1,200 pounds. Everybody who wanted to buy a grill bought a grill during COVID. Everybody was doing the staycation, sitting in their backyards, barbecuing. So we did thousands and thousands of grates and shelves for barbecue grills. And unfortunately, after everybody had one, people like Weber definitely had some problems because they actually filed bankruptcy after COVID because they were going gangbusters and everybody at some point everybody bought a grill and everybody who needed one bought one. So then all of a sudden it fell off. So but it was quite a run. And how to specify electropolishing? Initially you want to identify material removal and the desired finish. How much of the Surface material can be removed without impacting the part's intended function. Obviously, for a compression spring, you want to make sure that the parts are still performing, as engineered. You want to make sure that you're not, making the wire too thin. So, um, also, fixturing detail in critical areas of the part. We want to make sure that we're making electrical contact on the area, a non-critical area. Um, for instance, on springs, the valve springs, we actually we rack those end to end, so we stay off the coils, we stay off the OD. Um, but it just it's a matter of how the part functions, and we want to make sure that we're racking the part, in a non-critical area. Um, and as far as utilizing industry specs, I'd mentioned before ASTM 8967 is a commonly used passivation spec. For electropolishing, the most common is ASTM B912. It actually talks about using electropolishing for a purpose of passivation. So it's kind of nice to have a spec on the drawing. We can also provide Able specs as well, which are part specific. And then lastly, a lot of people don't think about packaging. We do a lot of fragile parts. A lot of people, you don't send out a lot of stuff for secondary operations. So one of the things that a lot of times goes unaddressed is packaging. So you want to make sure that it's packaged properly. With springs, sometimes you have springs that nest and that tangle. You may need to look at layer stacking the parts, or putting smaller amounts in bags if you are going to bulk. Here's just a mocked up drawing. You kind of we're gonna, if we figure on fixturing on the knurl, it's a good place to hide our rack marks. Um, and then kind of little, just a little some practical notes on there. Um, and then electropolishing, moving 5/10 per surface. So it'd be a thousandths diametrically. And then there we're certifying to ASTM B912. And then they've got packaging in cell trays. Cell trays are something that we do a lot, where the parts are actually put into an individual cell, and then the trays are stacked. Just depends on the fragile nature of the part. Mentioned a few of the specs before. Some of the ones that international standards that we adhere to, the ASTM B912 I mentioned, for electropolishing, but for purposes of passivation. ASTM F86, that's for implants. There's some guidance for electropolishing and passivation. ASTM 967 I mentioned is for passivation. That covers both nitric and citric passivation. ASTM A380 is another passivation spec, but has a lot more detail as far as secondary operations and testing. AMS 2700, that's for the aerospace group. We do a lot of aerospace work, and we're certifying to that quite often. And then nice ISO 15730 for electropolishing, something else that we can certify too. Limitations of electropolishing, as far as, we do rely on good current flow for the parts for the process to remove the material uniformly. We typically don't like things like adhesives, silicates from improper rinsing, from maybe a tumbling operation prior to electropolishing, burnt in oil after welding. Uh, typical uh, Typically, adhesives, one of the problems we run into, people buy vinyl coated materials. They peel, they peel the vinyl off, but then they leave this adhesive behind, which is very difficult to see. And it's can cause problems with conductivity with our process, and you get actual resist patterns. Um, since electropolishing is more used on the micro side, deep scratches, things you can feel with your thumbnail, rub across. the thumbnail. Typically, when you're taking 5/10,000 to a thousandth material total, your deep scratches are not going to be removed. Orange peel condition, you see that when people are forming either tubes or wire. You see that where the grain boundaries become very pronounced. The orange peel is something that we can't overcome. Um, Distortion from cold working. There again, nicks, dings, um, large large defects are typically not going to come out with the electropolishing. Spiral lines and in wire that's from straightening in roller dies. Sometimes we get that. We see that when we're doing wire racks, that type of thing, where they're not lubricating properly, and you're getting the spiral lines in the wire, which does not go away with the electropolishing. That's all I had. My section here. Did I miss anybody? I know that I saw the one question that come up. Did I miss anybody? Does anybody else have any further questions? Okay, let me just see this one here.
Hey, Scott, I just sent you some questions.
Okay.
Kind of a random series of questions as we went through the presentation.
Okay.
I can, ask them to you, or we can
Yeah,
talk about.
you want to just do it verbally, probably be just as easy.
Sure. So obviously the effectiveness on surface finish and that is obvious, but is it a tool to remove burrs or not remove burrs?
The electropolishing?
Yes.
Yeah, definitely it's used a lot for micro deburring. The big thing that you keep in mind that we're more on the micro level. It's based on the stock removal that we're taking off the parts, which determines how big a burr that we can take off. But it's used a lot for micro deburring. And as I mentioned earlier, it's the base of the burr that's critical, not the height of the burr. So
Yep.
we had that part with a little whisker on there that actually electropolishing could take off, but it's a very effective micro deburring process.
So what was the wire size of the medical part that you deburred in there?
Trying to think.
And then I guess the
Yeah.
add on to that is there a minimum size of a part that you can electro finish?
Yeah, let me give. Yeah, as far as I don't know the exact size of the material, but typically about the smallest thickness on like a sheet metal part would be like 4 thousandths. Probably on a wire, you're probably looking maybe like 10 thousandths because it has to carry current. If it's too thin, they won't be able to carry the current. But usually like 4 thousandths in sheet stock, and like 10 thousandths in wire. And then I'm sorry, what was the other question?
Well, it was minimum size of a part that
Oh yeah,
you.
our footprint of our largest tank it's 41 inches wide, 42 inches deep, and 102 inches long.
Okay. So I'm thinking of the process working on one part or multiple parts at a time. I kind of envision like when you're jumping a car and you've got this big clamp and you smash it on the battery poles. Is that kind of a crude way to describe what you do with the
Yeah, we
electrical?
actually, it's kind of like on smaller parts, springs and so forth. It'd be like grabbing it between your thumb and your forefinger. Be like a 2 point
Right.
contact. Um, and then you have a bus bar that's attached to the rectifier. So the parts are made positive, cathode's negative, and you're drawing those ions away. But you have to make electrical contact with the parts, with each
Yeah.
part. Um, Very similar to plating. Um, but we don't mix parts. We run. We'll build a rack, and we have what we call a universal rack system that we have rack makers on each shift that we can actually use different items to be able to put a rack together pretty quickly. We don't have to use outside services. And we have rack makers on each shift. So, but we don't mix parts. We'll set up the racks for your part, and because you can't mix parts because they're run under different parameters. So, you've got different temperature, different stock removal, and so forth.
Right. And then lastly, what's the typical removal, specification? I mean, I heard a thousandths and I heard half a thousandths.
Yeah.
And what do you typically remove off?
Yeah. Well, the typical standard is 5/10,000ths to 1,000ths diametrically, like on a spring.
Okay.
We can take anywhere from 2/10,000ths all the way to 3,000ths, depending on
Wow.
what people are looking to achieve. The 2/10ths obviously is like it's just like almost like a bright passivate at that point. But 3,000, some people have big burrs and they have no other way to take them off. They don't want to do them by hand. And we don't have a lot of jobs where we do that kind of stock move, but there is people who have requested that.
Okay, thanks.
Now I see some other questions. Jason, did you have some other questions?
I had just put on chat whether or not Able has any facilities on the West Coast. It looks like you guys are located in Midwest Chicago.
Yeah, we're in Chicago. It's our only facility here. We're centrally located. We got the 150,000 square foot facility that runs 3 shifts, 5 days a week.
Great, good to know. Thank you.
Sure.
And it looks like Terry Pratt had a question. Is hydrogen embrittlement a concern with this process?
It is not. It is not. The fact that we're on the anionic side, we actually liberate oxygen to the parts, whereas in plating they liberate hydrogen, and hydrogen typically gets trapped under the plating. They typically call for a bakeout, but the electropolishing does not cause hydrogen embrittlement.
Great question and great answer.
Yeah, it's something that comes up. I've actually worked with. We had a situation with Boeing. We were actually doing some landing gear for Boeing, and it was austenitic. It was actually martensitic material that we were electropolishing, and they had a spec that had to be baked out within 3 hours. Well, that's not real practical, considering that we don't do bake out here, and we were not. So it had to be messengered over to another outfit to do the bake out. But I actually, through testing, I was able to get them to eliminate the bake out process. But people, when they feel that the metal goes into an acid, that that you're going to have problems with hydrogen embrittlement. But it's been tested; it does not cause any problems along those lines.
That's a great answer. That's a great answer.
If I missed anybody, you want to speak up. Sorry if I. Yeah, go ahead.
Yeah, so the electrolytes you're using during the process are acidic, essentially.
It is. It's a phosphoric acid based electrolyte, and then what we do is we have proprietary buffering agents that we use to buffer the solution to the material that we're electropolishing. So we have like 8 different electrolytes that we make ourselves, and we use the different electrolytes depending on what the material is. So a carbon steel part is not going to be run in the same manner as, say, a stainless part. They have different removal rates, and in that we can fine tune. For instance, if you have burrs that are going to take a little longer to remove, we can actually structure it so that it's run in a bath that actually takes the material off slower. So we have it's an art as well as a science. So we have ways of being able to match up the proper electrolytes with the proper parts and material.
Okay. And maybe a secondary question relating with this, you mentioned during your presentation that the area where the part is to be racked is kind of important. So I guess there is potentially some strong currents that can circulate into the part. So is there a risk of arcing with this process if the contact is not well established?
It can happen. Yeah, it can happen. If the part moves or it's not secured, you could have arcing. It's very important, the fact that we make all of our own racks here, and but typically on a typical spring, you're gonna be grabbing it from 2 points. You're gonna grab it from end to end. In some cases, somebody might want us to grab it on a dimer, but we were able to minimize the rack mark, but there's potential for a little arc mark because we're actually transferring current from the bus bar to the rack to the part.
Okay, thank you very much.
Sure, thanks for the question.
Yeah, it's interesting. As Scott and I were having some preliminary discussions, I'd asked, well, can you show us some typical fixturing for springs? And that's considered to be proprietary technology, which everyone on the call can certainly appreciate.
Yeah, one of the things, we're a privately held company, and we, whenever we can protect our IP, we do. We have a closed shop. People, a lot of people that we deal with are dealing with a lot of very confidential applications, especially in medical and in aerospace. And so even though, we're a approved vendor for flight critical parts. I mentioned earlier an example for Boeing, and we can kind of explain to them how the parts are racked, where they're racked, but it's kind of the fact that that we developed all this over the years, especially the automation too. We've spent millions of dollars in automation to improve capacity, repeatability, and so forth. And we there again, it's unique to our company here, and everybody likes to have some type of a competitive advantage, and that and the fact that we mix all of our own electrolytes is definitely our competitive advantage.
Yeah. Very nice. Any other questions for Scott?
Yeah, if something does come up, hey, Rick, you could I could get you my email address if you don't have it, and they could, if they have a question that comes up later, I'd be happy to help them out.
I will do that in follow-up. And if there are no further questions, I'd like to thank everyone for taking the time to participate in this Electropolishing 101 class this afternoon. We hope you found the material to be useful, what you were looking for, and special thanks to Scott Potter for presenting today. And if you can take time, if you got a copy of that SurveyMonkey class evaluation, if you can fill that out, that'll be great.
Thanks,
Thanks
Scott.
again. Yeah, thanks again for everybody joining. Hope you found it beneficial.
Okay, very good. Thank you all.